Alright, our final example in this topic of compounding rates of return is a little trickier. Hanako invested in a stock that doubled in the first year and rose another 50% in the second year. Now, at the end of the third year, Hanako is surprised to discover that the stock's price is up only 80% from her purchase price. By what percentage did the stock's price change in the third year? All right. So, there are definitely options here. Let's put down what we know to start here. Let's start filling things in. The stock price doubled in the first year. So here I1 doubled, which equals an increase of 100%, or 1.00 as an actual value for I1. So stock price doubled, it increased by 100%. Year 2, it rose 50%. So plus another 50%, or 0.50. Year 3, we don't know what happened, so I'm going to put a question mark there. We can try to solve for that potentially, but I'll show you I'll show you multiple ways, but preferably an easier method to do it. What else do we know? So she was surprised that her stock's price was up only 80% from the purchase price. So this I'm going to call the overall change. From the very start to the very end, it was only an increase of 80%. So plus 80%, or 0.80. And we'll see what to do with that in a moment. We don't have VI. We don't know how much stock she purchased. But we are interested, everything is expressed as percent changes. So in fact, it doesn't matter what dollar amount you have, we're still going to figure out, other than, as long as you don't round it off or anything, we're still going to be overall calculating the percent change that occurred. And this will be the same for any dollar amount, other than $0. So $100 actually is a great number for working with percent changes, because it actually makes the percent change really obvious. If a $100 stock ends up at $115 at the end, then it's gone up by 15%. You can just look at that change and divide by 100 and multiply by 100, so it ends up as a percentage. So let's assume that we purchased $100 of the stock. Makes the numbers work really well. So assume $100. And like we say, that could be the share price, but even more likely that could just be the amount she purchased of the share. And because as those shares change as a percentage, then it will change also the total that she bought. Okay, we can't quite use the big equation yet, and in fact I recommend against using the big equation for this. I'm going to step through it year by year, and I think that will be easier. But let me first see, if you're good with algebra, you can definitely take a look at the overall equation. We have VI now, we've assumed $100. We have I1 and I2. We don't have I3. I think it is trickier to juggle the algebra here though. But we would then need VF. What's VF? Okay, well, we have the overall change. So if we start with $100, we know that it goes up and apparently goes down in year 3, but we end up at an 80% increase from that original $100. Again, you don't even really need a formula to say, oh, 80% of 100 is 80, so it's now up to 180. But I'll do it with an actual formula just to show. So yeah, let's do that. VF equals VI times 1 plus C, our good old original percent change equation. When we put the numbers in, VF equals 100 times 1 plus 0.80. So VF is equal to $180. So at the very end, we're up to $180. We now need to just figure out what happened along the way and what happened during year 3. And I'll show you what I think is a much easier way to tackle it. You have all the variables, you could put them into one equation and solve. If you can do it, more power to you. If you want to pause now and try, go for it. I'm going to show you what I think is a bit better way. Let's just do a quick table. Year 1, 2, and 3, the start value and the end value. So we're going to start at $100 at the start of year 1. This amount doubles during year 1, so times 2, right? An increase of 100%, it doubles. The end value is now $200. You can do this, you can do the percent change equation for each year if you like. That's easy enough. I didn't worry about showing the work. And I don't need you to show all your work on the test. That's okay, as long as you show some work. Year 2, starting value then is $200 now. What's the end value at the end of year 2? It's an increase of 50%. So 50% of $200 is $100. So we add that back to 200. We're now up to $300. You know what? In this case, sure, I will show. So let me show the calculation. So we have 200 times bracket 1 plus 0.50 is basically what we've done. Pardon, my numbers got small and messy. So that's equal to $300. Okay, so we started at $100. It doubled in the first year to $200. It then increased by another 50% to $300 during year 2. So now we're starting year 3 with $300 in value. We don't know what happens during year 3, but we know that by the end of year 3, we've been told the overall change is, from the very start was an increase of 80%. So that's where we use this $180. So that's from the overall change of 80% plus 80%. So the overall change of plus 80% from the $100 starting price. $100 start value. Okay. Now we want to figure out what happened during year 3. What's I3? So, while we can put it into this sort of formula here, I really recommend just using the other rearranged percent change formula, where basically we're starting at $300 at the start of that year and we're ending at $180. What happened? We lost $120. What is that as a percentage of $300? Divide by 300. So let's put that into the equation just because. So remember the equation there was C equals VF minus VI over VI. We'll turn it into a percent at the end. So that's $180 minus 300 over 300. So there's our loss of $120 from an original $300, and that is negative 0.40, which if we multiply that by 100%, we get a loss of 40% in year 3. And so that's our final answer. I3, so that's going to be we called it I3 or C, the percent change. But yes, this is looking at what happened from the start of year 3 to the end of year 3. We know we started at $300, we lost $120 worth of value out of that $300, that's a loss of 40% of the $300. So there's a lot going on in that question. It's definitely a little more complicated. We didn't give you any pieces of data you didn't need to use. You needed to use all of it. I think you just need to lay it out, and if you're stuck, just start calculating whatever you can. Even just, and oh yeah, the only thing we didn't give you was an initial starting price. But like I say, we were only interested in an overall percent change. So the initial starting price doesn't actually matter. You can see, firstly, what if I had said a $1 starting price? Okay, $1 goes to $2, goes to $3, and then goes to $1.80. It's a loss of $1.20 from an original $3. That's a loss of 40%. So, like any dollar amount would do, you can do $1 if you wanted to. Those who are proficient at algebra, you could have also taken the percent change formula. So we did need to use this for that 80% change. But if you say you didn't want to assume anything for VI, you could have set this equal to this. So here's one expression for the final value at the end of the 3 years. Here's another expression for the final value. If you set them equal, VI times 1 plus C is equal to VI times 1 plus I1 times 1 plus I2 times 1 plus I3. You can certainly do that, and you'll notice VI is on both sides of the equation, and you can just divide it away. Like I say, it doesn't, we're looking for percent change. It doesn't actually matter what the starting dollar amount is. So then you would end up with, well, 1 plus C equals 1 plus I1 times 1 plus I2 times 1 plus I3, and you can juggle it around and try to solve for I3. But I think doing it in separate steps makes this a lot easier than the algebra juggling that's involved otherwise. Okay, thank you for looking at some of the compounding rates of return with me, compounding percent changes. Next, we'll get into ratios.